Hi there everyone, this is Shahriar Kabir, a student of Tokyo Institute of Technology, and today I am going to share some of the techniques on how to create and export these kinds of illustrations for academic journals. This is the episode 1 of a series of video tutorials where we will look into different softwares and platforms so that we can generate 2D and 3D illustrations, different kinds of plots, graphs, and tables. In each episode, we will cover a separate platform. For example, Microsoft PowerPoint, Microsoft Excel, MATLAB, Python, etc. The idea is that we want to develop a very systematic approach to creating the graphics we need so that when we finally write our research report, it is going to look well organized and consistent. This is really important because no matter what is your research major is, you need to publish your research findings in a well-renowned journal. And the journals will always have very strict restrictions on what type of papers they are going to accept. Right now, I have the formatting guide of Nature in front of me, and we can see that this is a very detailed article on how to format our research paper. We should follow this article to format each section of the paper that we are writing and each figure that we are exporting from different softwares. We need to export 2D illustrations, 3D illustrations, plots, bar charts, pie charts, and so we need to be careful with the process. And that is the purpose of this whole video series. Depending on your research major, you will choose different journals, and so you need to check the author guidelines at first. If we look into the author guidelines of International Journal of Civil Engineering, we can see that they prefer vector graphics in EPS format and halftone graphics in TIFF format. So before creating your artwork, please be careful about these restrictions. Sometimes the journals will also give us different kinds of templates. For example, if we check the template for IEEE Census Journal, we can see that they are giving us the LaTeX template and the Word template. LaTeX is a very versatile and flexible platform, so if you are comfortable with it, please go ahead. However, the Word template is the easiest to visualize, so we will work with the Word template today over here. So in this template, all the sections are already well formatted. We just need to input our research data, our own research information in this template, and it should be good to go. They have also given us an example of how a 3D illustration should look like. The text is clearly visible, the colors are not too overwhelming, so they are not interfering with the text. So this is then an example of an acceptable 3D illustration for IEEE Census Journal. If we scroll down over here, we can see an example of a table. And one thing to notice over here is that the table does not have any border lines in between the columns and rows. So this is the standard format of tables in modern journals. Only the headers should have a bottom border and a top border, but the actual content of the table should not have any horizontal and vertical black lines. So please be careful about this when you are creating your own research tables with your research data. I'm sorry. Over here, we can see an example of a very good line graph. So the marker size, the x-axis label and the y-axis label, everything is very large so that it is clearly visible. Sometimes the default settings in different softwares will not create line graphs like this. So we need to take care of that as well before we export our plots and line graphs. Okay, so in today's episode, we will look into PowerPoint, Microsoft PowerPoint, because I think this is an excellent platform to create simple 3D artwork. We will discuss the techniques from now. So the first thing I will do is create a blank slide with the slide ratio of 16:9. And then I will turn on the guides and grid lines so that I can place my elements properly. If you think this looks too crowded, you can turn this off. No problem at all. Okay, so next I need to create a text box and I will put some random text over here. I will change the font family to Arial and then I will change the font size to 28. This font size of 28 points and the slide ratio of 16:9 is the most important reference for our illustrations. So I will use the size of this text as a guide to create each of the elements of our artwork. It will make sense when we export it, don't worry about it. Okay, so first I need to insert a rectangular shape like this. This will be our active layer. So I'm going to turn off the outline because it will not look good in 3D format later. Okay, next I want to create a duplicate copy for the gold electrodes. I will hold down Ctrl and Shift and drag. This one becomes a duplicate copy. I will change the shape fill to a gold color so that we can see it better. I want roughly this size. I will just make it a little bit shorter. I will duplicate this one more time, Ctrl and Shift, move it over here, move it at the top. Okay, so there is an overlap of the gold electrodes, which I really want. I need to create the ITO electrode right now. For that, I am going to hold down Ctrl and Shift again and then drag over here. I will resize it to something like this. I need to change the color to maybe something. This should be okay. I will move it over here to see that it also overlaps both of my electrodes. So I think yep, this one looks perfect. So I will get the text out of the way. After selecting all the elements, I can turn all of these into 3D illustration in just a few clicks. To do that, I need to go into Shape Effects, 3D Rotation, and then to 3D Rotation Options. Over here, the first thing to do is change the depth to a random value, maybe 10 is okay. We can't see anything happening because the depth is actually along the Z-axis. We are looking at the artwork from the top, so it is not clearly visible right now. So we can do that by going into 3D rotation, clicking over here, and for my device, isometric top up looks the best. I think it looks the best for my electronic device. For your research illustration, if some other rotation option looks better, please go ahead. Please try all of these out to see which one works best for you. I will select isometric top up, and now we can see all of our images have a depth and they are already 3D. We need to place them properly. I will select this one and then use the mouse to roughly put it into place and then use the arrow keys for fine adjustment. I will do the same with the second electrode. Use the mouse and then use the arrow keys to get it into place. I think that looks fine. Okay, and next I want to put the ITO electrode over here, but because we created this ITO electrode last, it is actually at the front of the canvas. We want to send it to back. Okay, so that is fine. But unfortunately, right now our active material, this is a solid block. It's not transparent or translucent. To make it transparent, we want to go to Effects and then Material and then click Translucent Powder. So now it has become completely translucent. Although the thickness is actually it's too thin, I want to make it thicker. So let's make it 60 points. Okay, nice. Now we need to place the ITO electrode at the bottom, but I cannot select it because this is in the way. The active layer is in the way. So the easy method to actually select the ITO electrode or any element that is at the back of the canvas is to go into Shape Format and then Selection pane. We can see that right now Rectangle 2 is selected. I want to change the name to Active Layer. And then I want to turn off the visibility. Now I can easily select the ITO electrode and I want to change this name to ITO so that I can refer to it later. I want to select ITO and turn on the visibility of active layer, and then I can use the arrow keys to put it properly into place. I want it at the middle, so in the middle, that looks fine. I'm happy with these the position of these elements. I want to create the silicon substrate. For that, I will hold Ctrl Shift again, drag it down. I duplicated the active layer, so this is also translucent. I want to make it warm matte. All right. Again, this is in front of the canvas. I will send it to back. I will roughly put it into place. All right. For me, this silicon substrate looks just too thick. I want to change it to maybe 40 points. That looks fine. All right. So I am happy with the image. So I would like to group all of these elements together so they don't move around unintentionally. I can do that by going into shape format, group, and then selecting the group option over here. So now they will move together like a single block of elements. Okay, so I will put the text over here. This is going to be the gold electrode. I want to duplicate it for the active layer. I want to duplicate one more time for the ITO electrode. I want to do it one more time for the silicon substrate. So this one, let me rename it. This is the ITO electrode and this is the active layer. Okay, because the ITO electrode is actually inside the active layer, I would like to create an arrow to indicate that I am actually labeling this ITO electrode. So I will make the arrow, the stroke of the arrow thicker, and it will be black so that it is easily visible. Okay, so now that we are happy with our artwork, let me just close these so you can see it better. We can save it. Of course, we can click the save icon over here to save the PowerPoint slides in PPT format, but many journals will not accept the PPT format of your illustrations. You need to submit them in either TIFF format or PNG or PDF format. So we have to go over here to the save as option and then change the file format into PDF, PNG or TIFF. Please do not choose JPEG because this is a very low resolution and small file size format. It is used only in web publications for saving images that will be viewed on screen. So we need to choose TIFF or PNG for high resolution of image export. I hope that made sense. For this purpose, we will just choose PNG for now. Let me give it a name and then save as just this one so that we are only exporting this slide. Let us see how it looks like. It is quite professional. It is quite nice. However, let me show you guys the image that I showed you at the beginning of this video. This image is actually at 300 dpi as recommended by the journal author guide. This one is only at 96 dpi because PowerPoint's default export resolution is 96 dpi. Therefore, we need to change the export settings so that we can get high resolution output from PowerPoint. To do this, we have to follow the guide that is over here, already given to us by Microsoft. This link will of course be down in the description of the video, so please check it out. The technique is actually quite simple, so I will just walk you guys through the process. It's not very difficult. The first thing we need to do is close PowerPoint and then go to Registry Editor. Click Yes. Now we are in the Registry Editor, and I think this is how the Registry Editor will look when you first open it. We need to go into HKey Current User, go into Software, and then find Microsoft. Over here, we need to scroll down until we see Office. Okay. Now we can see there are 3 folders, 14, 15, and 16. This is depending on the version of PowerPoint you are using. You need to choose a different folder. So if you are using PowerPoint 2013, then you need to go to the 15.0 folder. If you are using PowerPoint 2016 or later, then you need to go to 16.0 folder. For me, because I am using PowerPoint 16 or later, I will go into 16.0, go into PowerPoint, and then finally over here to options. Over here, we need to right click and then create a new dword of 32-bit value. We need to name this dword into export bitmap resolution with this case. The E, B, and R must be capital, while the other letters must be small case. Okay. Next, we need to right click on this word and then modify it. Click the base to be decimal and then the value to be 300. So this is going to tell PowerPoint to export all the images. The bitmap is just an image format, to export all the images into 300 dpi resolution. So the important point is changing the base to decimal and then selecting 300, because the hexadecimal value is different. Please remember that one. This is really important. Okay, we will close registry editor and then fire PowerPoint again. Select our slide, go to save as, and then select PNG. Give it a different name. Something like this will work. We will export just this slide and then check. This was the image that we created earlier. This is at 22 kilobytes, and this one is the one we exported right now. This is at 110 kilobytes. So definitely this image is at 300 dpi. The other one is at 96 dpi only. So this is the proper way to actually change the export resolution of PowerPoint slides. Now that we have changed the registry key value, it will be saved, and from now on all the images will be exported in that same resolution. So that is good news. We would like to check how our image actually looks like in the actual template. So I will delete this image over here. I will copy our new image and then put it in the template file. Our image is very large, so I need to resize it. I can do that by going over here. I think 1.9 inch looks nice. There is some white space at the top and bottom. I need to crop it down, so I can do that by clicking the crop option, and let me resize the text box. And now you can see that it looks very professional in the template as well. The text size of the image and the text size of the main body are roughly similar. So in my opinion, this is a very professional way to write our research paper with illustrations. Okay, so this is completely dandy and fine, but what will happen if our image is not so simple? What if there are many elements into in our image that we cannot fit them properly in this canvas size? In that case, what I will recommend is using the 2-column width image format. So this one, this 16:9 ratio and 28-point Arial font is best for viewing the images in 1-column format. If you want to use your images into the 2-column format, obviously you need to change the font size to 14 points, and now you can resize all of these elements of the images according to the size of the font. Therefore, you will have a much wider canvas range to actually work with. If still it is too complicated, then I will recommend simplifying your image instead of changing the font size to lower values. Because if your image is not properly visible, if the labels are not properly visible, that image will actually, it will not serve any proper purpose. The purpose of creating an illustration is to provide an clear explanation of what the device looks like, what the flow chart, what the algorithm looks like. So please be mindful of the labels and the clear concept that you are trying to give to the readers of your paper. Okay, so that is about it for this tutorial. This template file and all of the links that I showed during the video will be in the video description. So if you need the information, please check it out. I understand that I only showed a very simple illustration and that is only geared towards electrical engineering students. But if you have any questions about PowerPoint or anything else about academic illustrations, feel free to use the comment section to ask questions or give me suggestions. I will help. I will try my best to help if there are any problems or any questions. Okay. The next episode of this series will be on Microsoft Excel. So I hope I can see you guys over there as well. Thank you so much. See you guys next time.